Hi everyone, good afternoon and welcome to today's live coding session. And as stated on the Slack channel, we will be working on Docker because this current stage deals with containers. And anytime you hear container, the most popular option that comes to mind is the Docker container. So there are many other different kind of containers, but Docker is the industry standard and what is being widely utilized today. So today we'll just be using a playground. Not like this, I use Docker desktop, but I want us to see a playground today where we can just like, it's also similar to what you guys will actually work with for your lab assessment. And also I think we doing it here is also in a way going to like either you guys get more familiar with this and stuff, and then based on what we do today for our next live coding session, I think I'll just work on probably spinning up a Docker container for a web app or something like that. So to start that, I'm going to come here and search for Docker playground. That is our search term, and Docker playground is actually provided by Docker, the Docker guys themselves actually, for people, because Docker is something that is a little bit heavy on systems that are old of sorts. So systems that the processor are old or something, Docker takes quite an heavy toll for it to perform all of its functions on systems like that. So that's why something like this was created to ease the burden on people that don't have that enough working, enough processing power for them to be able to use Docker effectively, at least to be able to grab the basics and showcase your skill in whatever it is I want to do. So Docker, okay, I thought I clicked on this. So this is the Docker playground. So play with Docker is the Docker playground that we're going to be working with. They play with Docker. There are different, actually, they have like different hands-on tutorials. So you guys can come here. You see, they have like tutorials, they have a live environment. So this one we're going to be working in. So this lab environment is provided to us for, I think it's an hour session or thereabouts. So normally you are meant to use Docker desktop and Docker, but I think with this lab environment, you have all of the functionalities of Docker online without having to take everything to your local system. So you can work with Docker commands, play with containers and stuff like that. And the session they give us is provided for 1 hour. So I should click on this and let's see. Okay. So I have to log in first, Docker. Okay. Okay, so the screen might be frozen. I'm actually trying to log in. I'm doing that in another screen. Okay, so I think I've logged in successfully, exactly, and now we should be able to start. So let's click on the start function. Okay, so this is provided to us for 3 hours. So I'm going to click on a new instance. Okay, so this is it. So this is provided to us. I don't know, people that use people that use shell should recognize something like this. So this is basically a shell, like an Ubuntu stuff. So where you can just like use, so if I click on Docker, so exactly we have, you see this is the Docker command. Okay, exactly. This is Docker options and commands. So these are a list of different commands that we can use, and a list of different things that we can just do with Docker on containers. So to create any Docker container, so I might have to explain this, but this is also explained in our note and slides. A Docker container is actually you can think of it as a virtual machine of sorts, in a sense where you need something to be like, for example, you guys should know what a zip file is. So you guys should have worked with zip files at one time or the other. So the way zip files is in the sense that you want everything, let's say you zip a particular folder. So no matter where that zip file is moved to, as long as it remains in that zip folder, anytime that zip folder is extracted, the content that was zipped into that folder, they remain intact and they remain compact. So for example, when you're copying files, people that use Windows or any other stuff copying files, there might be an issue. Let's say you're copying to an external flash drive or something, and the external flash drive gets disconnected accidentally. So there's like at the point where the flash drive is disconnected, there's like a break in transmission. So it's either the file you were sending at that point in time gets cut halfway on the flash drive, or only part of the bit of the file are sent. So there will be an issue with the file. But if you were to be sending a zip file, once there's a break in transmission, there is no like cuts in the fact that the zip file was being transferred. The zip file will just not open, or it will not work. Why? Because the number of packages that the zip file, the number of things that are required to be in that zip file, they are not complete yet already. If you get what I'm trying to say. So in a way, that is what Docker tries to do. Docker tries to it provides us with a way to, the terminology that we use is to containerize apps. So when we containerize apps in Docker, we ensure that no matter in any environment, what we mean by environment is, let's say, a new operating system or a new hardware somewhere, in any environment that app is being taken to, the contents of the app remain what's untouched, they remain what's unmodified, and they remain the way it should be. So with Docker, we build a container and bundle all of these things into a container and then push it out. So any kind of thing at all can be bundled into a container. You can just bundle files. You can use containers to keep files that you want to keep for later. It's a way to store files, and it's a way to like move from your development to your production. So most times when we are developing locally, so we have to like, well, Node.js now, you have your package, your JSON, your package manager that does what gives it all of your dependencies. For Python, you have pip and stuff like that, or you might be using a virtual environment where you install a list of things. So let's say you are collaborating with someone, or for people that have contributed to open source one time or the other. So when you're working on open source and people, other guys now want to contribute on what you're working with, they might not have the exact same requirements or the exact same dependencies that you have installed on your system, basically. So if they don't have the exact same dependencies that you have on your system, so there will be an issue for them to work with whatever it is that you created. Why? Because on your own system, you have those things installed and you are working with it and it works perfectly. But on their system, it might not run correctly. Why? Because there's a difference in issue. But using Docker container takes away all those issues, because they're able to bundle all of those your requirements, all of the things that you used to work on your own local system. You're able to do what? They're able to bundle it and add it into a container. So what we actually need for Docker containers is a Docker file. So a Docker file is a way for us to build what Docker images. So it's like in 3 steps, a Docker file that lists what are in the images. So after listing what are inside the images, we then do what? We have a Docker file. That's the Docker file is where we say, okay, these are the things that will be in that image. And then that Docker file is used to create the Docker image. And then after creating the Docker image, the next instance is to spin up a container. So a container is like you spinning up a new laptop or bringing up a new hardware and then placing your Docker image into that container allows you to see what to access the files that are in that Docker image. So the Docker image is what you pass around. You take your Docker image from your local system, you take it to Docker Hub, you can take it to GitHub, take it to Azure and stuff like that. Then those Docker images that you provide are used to what spin up new Docker instances, Docker container instances that we use. So the first thing that we're going to work with is a Docker file, and I'll be opening an editor. Okay, so let me see. Let me try something. I don't know if you guys can see the screen. Okay, so let me come here and just do ls. So I will just be showing us a little bit of difference in something. So this is our node, our local system where we are. You can see what we have roots. This is like the root user. So there's no file there. When we list ls, there's nothing on it apparently. So what I'm going to do is I'm going to create a file. Search DOCK Docker file. So when I list this now, there's now a Docker file here. So for us to work with this Docker file, so I think I'm going to have to like make this share rather than a tab. I'm going to have to make it a window, because apparently it's opening a pop-up. So you can see they try to provide us with, I hope all of my window is being shared now. So what they are trying to do is that when I created a file here, okay, and the file that I created here, so for me to see it, if I do ls now, you can see the Docker file. If I click on this editor function here now, this Docker file that I created here is what it is available. So yeah, now I can type in what's that Docker file. I can type in the details of that Docker file. But should I just use Notepad++, and then using Notepad++, I can then move those Docker files. I'll just upload them here, so it is faster for me to work with that way. So I've opened a new Notepad++, and I'm just going to create a new file. I'll just create a new file here. Okay, let me name it, save it for Docker file. So there are keywords that you have to use in Docker file, just like it's just like when we wanted to create a Docker file to do what? A Docker, when we are creating an action file, a YAML file. So when we are creating a YAML file, we see that there are a lot of keywords. We use things like stages, like test and stuff like that. These are things that are required to exist in a Docker file, if you recall when we were talking about action. So there are keywords that need to be utilized when working with Docker files. So I'll just show this screen here for the editor. Okay, so for us now, the first thing that we're going to be creating for today is that we're going to be creating a Docker file for an Ubuntu image. So the Docker file that we'll be creating is for an Ubuntu image, and then we are going to use that Docker file to spin up a container. And then after spinning up the container, we will then log in. We are going to use something called SSH. So we're going to do a secure sign-in into that container, and then see like a difference in things that we'll create things in the container, see them, and then see things that are also not inside the container, so that we'll see like the way like you are going to have a virtual machine where whatever is on your own system can be replicated there, and you can also have a repeat of whatever is on your system in that container. You can do other things on your own system that you don't need in that system. So that's the first one we'll be working with, is an Ubuntu image file. And to do that, okay. So I hope you guys can see the editor I am working with now. Okay, so to do that, as I said previously, we have commands that are required for us. So the first thing we need to do is to do that we have to set the base image. Okay, so to do that, since I said I'm going to be using what? I'm going to be using what? Ubuntu. So form is where we set the base image for any Docker file. So form means that, okay, I want you to get what? The base image that, or you can just use, you can just abstract it as saying that, okay, this is the operating system that I want to use for what? For this image. So anytime a container is pinned up, the operating system that that container will have is going to be what? An Ubuntu image. If it were to be Windows, you would have specified Windows, and maybe just with the other softwares apart from Windows, and I think Mac is the only one that is not available. We have Linux distros and Windows that you can pull into the image. So that's just in an abstract level. You can pull other things apart from OSs as the base image. So in a way, you can pull Python as a base image. So any image that has been created previously, any image that can be used to spin up a container can also be pulled as your base image in your Docker file. So that's the first thing we have done. We have set the base image, and we have done what? The next thing we are doing is to what? We are going to set the working directory. So the reason why we do this for Docker is so that we are able to know where to route to, because it might be in a situation where we want to go to a particular folder and we don't know the starting points of that folder. So we have to setting up a work directory enables us to know that, okay, this is where we are going to start working from. Anytime our container is open, I know that I'm in a folder that is called in this folder that you specify. So our working directory is going to be called app. It can be named anything, but that is probably the standard that people use. They use app, especially when you're building a web app or something. And then since I'm building an Ubuntu image, since I know I have this already, I can begin to build commands that can be run on that image even before that container is set up. So I would have loved to do is so when the command is run actually, but the reason why I will not do this is because doing one apt get and out of it is going to take a lot of time and also going to take a lot of space. And when you're on Docker the playground that we are on, we cannot really we don't really have the ability to expand overly, but it takes it. So the command that we are going to use here is called the run command. The run command is it allows you to be able to do as if you were working on the command line of that base image or the command line of that operating system in an abstract level. So for people that have used Ubuntu or anything at one time or the other, they will understand what it is that I'm writing here. Apt get installed. So these are things that once you log into the bash, for example, now if I do something like apt get, okay, I'll just showcase that in the next one. So this is the editor that I'm on. So apt get installed, but I'm going to comment that out, and because I don't really need of it, I just want to showcase the functionality. I'm not really doing anything much. And then we can have a command. This is not actually really something that is required, but it is always good, because when you start up a container, you want to start in a place inside the container. So when you use the cmd command, the cmd command is what I want to use, cmd command. So this cmd command says that this is the command you want immediately the container is on, immediately a container has been spun up. When you do things like run apt get and run, these are done when the image is still being built. You get, there's a stage where the image is going to be built, and then that image that was built is now going to be used to spin up a container. So for that image, you can begin to provide commands that will run after a container has been spinned up based on that image. So based on this, now I'm going to do bin/bss. So this is just me saying that once the container has been spinned up, in that container, I want you to run this command, and with this, I'm going to have so anytime I spin up a container and get into that container, I'm always going to get into the command line, or the bash. It's called bash. With Windows, we use command line and PowerShell. So I'm always going to get into the bash. You get the CLI of that of this Ubuntu image. So I'm going to save this now. So this is something that we could have done not even using the editor, but I'm someone that I like GUI more than I like GUI more than stuff. I like GUI more than command line tools, but in the end, they are going to have to use command tools at all, and I'm not really in it with Python. So now that that is done, I'm going to change my sharing. I'm going to go back to our playground. Okay, so I hope I'm on our playground now, and then I think I can edit this. Okay, so now if I come here, sorry, I have to like do this. Can you go down? Thank you. Okay, exactly. So if I come here now and say that I want to list, so these are Linux keywords, so it's not really something that I can say, but if you check it, it's just like for command line tools, there are things that are specific keys that you can use. So if I say I want to cut Docker file, that's cut is like show me the content of Docker file. You can see that what everything that I have done in the editor now is what inside this Docker file now. You get set the base image, set the working app directory and stuff like that. So the first thing I'm going to do is that what I'm going to build this Docker image. So this Docker build. Docker build exactly with a one argument. I see. So this should actually work normally. So what is happening? Okay, Docker build dots. So the reason why I did not work at first is because you have to specify where the Docker file that you want to build is in. So I know that the Docker file that I want to build is in this file. So you can see that the Docker file does not have any extension. It is just capital letter D and Docker file. So you might have, it's not necessarily that you want to name it inside the folder now. You might have two Docker files where you don't want to use the standard Docker file. But the way Docker is set up is that anytime you use Docker, it looks for a file called Docker file with a capital letter D. If you save it with a small letter D to also throw up an error, it has to be a capital letter D OCKER FILE. So if I do Docker build dot, so this is me telling that I want to build the Docker file in this directory. So let's say I had the directory of sort, let's say a Python directory or something, blah blah blah. But I know that I'm just in this directory, so I'm just going to build the Docker build dots. And now you can see that our Docker building is running. So this is the process of building the image. It runs it sequentially. So you see that the first thing we did was to what? From this part here, this is the part where these are the internal things that have to be done. This was the first thing. If I can open up our Docker file back here, you can see that we have just two things. Number one, we said that number one is to what? From pull the base image. And number two is to what? Set the work directory. Number three is to what? Run this command. And then this is the last thing. So if you come here, you see that it has two things that it is doing. The first thing that it is doing is what? It is what? Pulling this base image. The reason why we don't have three things here is because for this part, remember that I said that I commented this part out because this will actually take a lot of time and installation space. You can see that we have a way that we are monitoring this here. So that's why we have those two things. So the first thing was to what? To pull the Docker image, and the second thing was to what? To set our working directory to app. But you can see that there's also a third thing, which is the last thing, the CMD. So this one will not occur until what? A container instance has been spinned. You get a container instance has been spun up with this image that we just created. So to spin up a container instance with this image that has just been on, so we're going to have to use Docker run. Okay, if I do this now, so I think for us to view the images that we just created, okay, so I'm going to say Docker images. Okay, sorry, I didn't know that I was on mute before. Sorry for that short break. So if I say Docker images, you can see that we have what non blah blah blah, but this is the image ID, and it was created 2 minutes ago. And the image size is 72 MB. So this was even without even warning and getting the update and stuff like that. If you had decided to get all of the updates and stuff like that, you would have had an image that is actually very, very large. So with Docker images now, the next thing is to do do the Docker run command. So with the Docker run command, I can run a container based on the image that I just created. So I'm going to do Docker run, and to do that, I have to provide I have to provide the image ID. Oh, sorry. So that's Docker run. Let me just type this in FC058. Okay. So as I was saying, so we're meant to run a Docker container based on that image that we just spinned up. So I'm going to do the command is to do Docker run, and we're going to provide the image ID of that container. So the image of that container is going to be FC 0587433C20. Okay, unable to find image. I see. There's no tag on it. 743320. Oh, I think I did this twice. So once I run this container now, this container has been run successfully. So I'm also now going to type in the command for me to see the container that are open at the moment. So I'm going to do exactly. So it's Docker PS. That is what me saying that I'm listing the running containers, but I'm not seeing any container open at the moment. Okay, I'm coming. Let me build this image again, and when I'm building it, let me provide something. The build image okay. Oh, the repository is not. Oh, I see. The dots and I'm going to target what we are being provided with. The better the connection, the faster you're able to interface with it. So some of the things that type are coming up a little bit slower. So let's see. So I'm going to target Ubuntu img and I'm building it from this directory. Okay, so enter. Exactly. So now if I do Docker images, and now you can see that we have what Docker. It now has Ubuntu image, blah blah blah, still the same image ID. So now I'm going to do the Docker run. Ubuntu img. So if I do Docker PS, I should see. It is not working. HDSC. Option image. So that's the image. So don't know why I'm not okay. Image name is Ubuntu. I cannot see the Docker. So normally I should have a container that is up based on this image that we're going to. I can't seem to see why it is not coming up. So let me try another. So I'm going to do Docker run. Name. I'm going to call it Ubuntu container, and we are going to be using our what? I see. Exactly. So using this now, what I just did now is I didn't want to use this method before, but I don't know why that was not working, because this now, when I say Docker run name blah 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 and stuff. So what I mean when I mean it's, that means I want to, is a Docker command that you specify that I want to create this container and immediately move into the shell of that container. But I wanted us to create the container first, see the list of the container, and then do an SH into the container. Due to the fact that it's a that was not implemented. So with this, if I do an ls, for example, so this is lagging because I typed this already, but the fact that network connection is not strong up is why some of the things I'm typing in are not coming in here automatically. Okay, so this is Okay, I'm back. Sorry for that. But I don't know. The funny thing is I bought the Catis router some time back just to not have this kind of issues. But I don't know why I still get into network issues sometime back. But we're almost done. So I think it's also the fact that using the Docker playground. So it's on the network. But I hope you guys can see my screen now because I don't know I'm doing like this. We'll meet again for the next live coding session. Hello, can anyone confirm if they are seeing my screen? Don't know what's not stable. Sorry for that. I think the issue is with the network provider because it doesn't really happen. I got this Catis router some time back and most times I get stable network, but I don't know why this issue is persisting today. But if my screen can be seen now, so I'll just try to continue. So as I think this was where I stopped the last time. So now I'm into the container. So inside the container, I'm going to try and list the things that are present in this container. We can see that there is nothing there. So as I was saying, the Docker run command, saying it means like you telling Docker that once this container is run, I want you to execute a shell immediately. So I would not have wanted to use that in the first instance, but I don't know why. I think it's because of this playground, the normal Docker run, and just specify the image name is not working. But since I'm also in an Ubuntu, I can also do things like touch. Let me see, I name this sample.txt. For example, I can do something like touch rest.txt. Okay, so if I list this, you can see I have two files there that are called this. So immediately I get out of this container, so now I've gone out of that container. If I do a docker ps now, there's still no container. So I think that is what is happening. The container is actually opening and closing automatically. So but normally we should have a container. If I could create a new bash or a new instance, I would have liked us to see spin up different containers and we see what that container contains. But if I do an ls now, You can see that in the Docker file, what we have here is here. So everything that was created in this instance here was done inside where was done inside the Docker file, and does not have any correlation with what it is that we are doing outside the Docker file. So if I do something like okay, let me try to, I want to edit the Docker file that we have here. So I need to change my screen. Let me change to this current screen now. So I want us to add something to this Docker file where we do what? We copy. So this is the copy command. So I want us to copy everything that is in this folder, copy it into the app folder, basically. So if I do that and do Ctrl S to save the file, not this, and I save the file. So after doing this to save the file, I'm going to close the editor now. Let me switch back to the normal playground. Okay, so now I'm in the normal playground. So if I do a cat Docker file now, you can see now that we have something called copy. So in our current directory where we have, let me create touch sample.txt now. Touch HDSC.txt. So I'm going to write something. This is a sample file. And I'm going to send it to the what? I'm going to send it to sample.txt. Should that be cat or echo? I think it should be echo. Exactly. So that was I'm going to change this to echo. I'm actually getting this prompt that my internet connection is unstable. So it's actually causing. Okay. Okay, echo. This is a sample file. I'm going to echo this into the sample.txt. Okay, so if I do a cat sample.txt now, I'm going to see what I just wrote there. So if I do a list, okay, I have the Docker file, I have the rest.txt. Let me also write something into the rest.txt. The rest. Okay, and I'm going to send this into the rest.txt file. So after doing this now, so after creating both of this now, so I'm going to restart the docker build command, docker build, and I'm going to build this directory. So doing this now, we can see now that we had 3 steps rather than 2. First was the pull the stage, and the second stage where we created the working directory, and now the third stage where we copied everything that was in this directory that we're building into the working directory of the Docker app. So I'm now going to try and run this Docker stuff again. Okay, sorry. This build I just created, I did not name it, so I'm going to name it. Let me name it Ubuntu 2. dot. Okay, so now if I do something like Docker lists or Docker images rather, you can see that now we have what 3 images. The Ubuntu image, this was the one that I created without naming, and then this is the last image. So I'm going to do a Docker run it. Docker run it Ubuntu 2. So you can see now that using Docker run it, I'm into the Ubuntu 2, and if I do ls, you can see now that aside the Docker file, I also have my rest.txt and sample.txt. If I do a cat to rest.txt, I have what I inputted there. If I also do cat sample.txt, I also have what I input there. But let's say now I do something like move. So let's say I'm renaming sample.txt. I'm renaming it to, okay, there's no stationary variable. I'm renaming sample.txt. I'm renaming it to sample2 or sample1.txt, and I press enter. If I do this now, I should see sample1 rather than sample2. And if I do a cat of sample1.txt, I have this is it now. So I have done what I've done an operation of renaming to this. Let me also try and edit. Let me edit this rest file. Echo change into what rest.txt. If I do this now and enter this, if I do a cut of rest.txt, I should see what rest and change. So I edited something to this now. So this is me now. I created a Docker image. In the Docker image, I made sure that I copied the files on my local system. I copied it into that Docker image and bundled it as an image. So I now use this command to do what? I ran that image. I spinned up a container using this image, and what IT is just me saying that execute a shell for that container. So if I do the exit command now and exit this, you see that the actions that I ran inside that Docker container, they are not replicated in our actual machine that we're working on. If I do an ls, the first thing that we should see is that we should not see sample1.txt. We should also see what sample.txt. And if I do an echo to rest.txt and enter, you can see that the file, I that I rest.txt, the line that I appended to string that I appended to the txt file, the line that I appended to txt file is still there. So if I do a cat rest.txt, you should see that now I should not have something like change there. I'm only going to see the I rest that I did the last time. So our time is already fast paced. The network actually made a bit too, and I'd like to show us another container, spin up another image that actually utilize Python as the base image. So with that, we are going to come to the end of this live coding session today. Everything that I've done here and more showcased for our tag along code session for this stage. So for our next live coding session, we are going to be working with a Docker container that contains a web app most likely, and that web app might be deployed to Azure, and we'll also probably see the use of Docker Hub as a GitHub alternative for containers. GitHub is a repository for posts